Very good morning to everyone. Myself, Rohit Salecha. I've been with Not So Secure for the past three and a half years, and in the information security for the past 9 years now. Let's talk about what we're going to learn. What we're going to learn today. So this is an introduction to DevSecOps, and we'll answer the three main questions. That is, what, why, and how of DevSecOps. Right? Then we look at certain ways in which we can integrate security in a DevOps pipeline. What are the different tools of trade? What are the different, we'll also go through some sample implementation. And finally, we look at some cultural aspects around DevSecOps. A disclaimer here is that I'll be listing a lot of tools, which is definitely not an exhaustive list. I do not endorse any or recommend any specific tool or vendor. Every environment is different. Please test and validate before implementing any ideas. Now, how would you define DevOps? So DevOps, as I would define it, is nothing but continuous integrity, continuous integration, continuous delivery, infrastructure as code, and continuous monitoring. Now, what are these terms? In continuous integration, we have multiple developers who check in the code into a central source code repository. So every developer is checking in his part of code, and it is continuously being and the code is now being continuously integrated without any manual intervention. In continuous delivery, we have servers like Jenkins, Travis CI, Circle CI, etc. that basically pull the changes or pull the source code from the software code repository and then perform two actions. First action is to create a build or an artifact, and second action is to deploy that artifact. Now, where would Jenkins deploy these artifacts? If the Jenkins is deploying it on a static system, that is a virtual machine that has been created and a web server has been manually installed on it, then you're not truly doing DevOps. In DevOps, all the systems, all the servers, all the databases, and all infrastructure is basically spun up using simple few lines of code. And one of the most popular tools that you must have heard of is Docker, and that's what we're going to discuss today. So Jenkins basically creates a Docker, bundles the entire application and creates a Docker image of that particular application or that particular server. So let's say if we have a Java application, Jenkins will create a war file, and it will also create a Docker image of a Tomcat container containing that war file, and then that Docker file or that Docker image is then pushed on to a repository, public or private, from where it is pulled on a Docker host and then executed. Now, DevOps is a fast-moving environment. You can, in case of any issues or in case of an outage, you cannot really have your operation team to go and SSH and fire the tail commands and analyze the problem in the logs. You need to view the logs continuously at real time, and to use that to enable that, you make use of the very famous technology of Felk. Felk is FileBeat, Elasticsearch, Logstash, and Kibana. The combination of these three technologies these four technologies helps us in aggregating the logs, visualizing the logs, and also alerting in certain instances. This is a sample implementation of DevOps, where the developer checks in the code into a central repository, and Jenkins pulls the changes from the central repository. Now, Jenkins will perform two actions. It will create an artifact and push it into an artifact repository or any small server which can from where the artifacts can later be retrieved. And the second part is it will create a Docker image of our application and push it into a Docker registry. Now, the staging and the production hosts will then pull the latest Docker images of the application and deploy our application. Now, in our production application, we have the FileBeats application, which is taking the logs from our applications, pushing it into Logstash, And from Logstash, the logs are then parsed into Elastic, and Elastic is then and Kibana is then is used to view, is Kibana is used to visualize the data stored in Elasticsearch. Now, as you can imagine, in this entire operation, everything is absolutely automated. From the time the developer checks in his code till the time that the application goes live into staging or the production environment, everything is completely automated. And in such kind of organizations, generally the builds that go out at a very rapid pace. At times it can go out at every hour a build is being pushed out, or maybe like Amazon, the entire Amazon ecosystem, AWS, Amazon.com, everything is changing at a rapid pace of 14 seconds. If you're more interested on infrastructure as code, continuous integration, continuous delivery, continuous monitoring, feel free to have a look at these blogs. Now, what are the challenges for security in a DevOps environment? Now, as you know, DevOps is a rapidly moving, very fast moving environment. Every hour, every minute, every second, changes are being deployed into a production environment. Now, in such an environment, it is it is a big challenge for the security team to ensure that there are no security vulnerabilities or application security issues being pushed into the production environment. But then how will the security team do that? You cannot have a single person dedicated to an application to check before a build is being pushed into production to go and check if there is any SQL injection or cross-site scripting. Because by the time the person is finishing to check of the first change, the second change is already ready for deployment. So this is how DevOps really moves so fast. Again, here we are just talking about one single application, but many organizations have multiple applications like Google and Facebook. They have multiple applications that are continuously being pushed onto the internet. The changes being continuously pushed onto the internet. So what about the scalability? So here again, you cannot have security team gatekeeping your applications. You need an automated approach. Again, with DevOps, the attack surface is increases because, for example, once we did a red teaming for an organization, and we had access to the Jenkins instance. Now, gaining access to the Jenkins system, we were able to exploit 500 different applications to which the Jenkins was pushing code rapidly into production. Right now, another thing that's very much lacking is skill set, because in a DevOps environment, the devs are because in a DevOps environment, the devs can no longer say that we don't know how to push applications into production, and the ops cannot say that we cannot read code. So the skill set required for for performing a DevOps and for performing the DevOps operation is definitely high. Now, in case of security, in a fast-moving environment, the skill set required is a lot more. So the DevOps engineers not only need to know about their own DevOps projects, but they also need to know about security and what are the different vulnerabilities and security. Now, generally, what organizations do is once the application is running, is fine, and is running in production, it's when people realize that they need to perform a security testing. And what are the things that we perform in under the umbrella of security testing? We perform source code reviews, we do dependency checking to check if there are any vulnerable dependencies in our application or not. We perform compliance reviews, we perform automated security scans, we perform penetration testing, and we also look at security incidents and responses, right? Now, the problem with this approach is that if a single SQL injection or a cross-site scripting bug is identified in the production environment, then it is a lot more expensive and it costs a lot more than fixing it in a staging environment, right? So so this is the reason why it is a lot more advisable to move the code, to move the security testing a little towards the left. So for example, you take even the most simplest static analysis security testing static analysis security testing uh, tool, and push it in and push it into the pipeline, right? What you get is what you get it can very easily identify a SQL injection vulnerability. Now if you move that into a secure into if you move that uh, into the pipeline a little more before the application gets deployed into the production, then what you get is that the vulnerability is identified a lot more earlier, and you don't have to fix it into the production environment. You are fixing it a lot more earlier into the staging, even before the application actually reaches the staging environment. Now, not just the normal code review, but what about if you perform the entire suite of all the security testing, that is compliance review, the penetration testing, your dependency checking, your automated source code review. If everything is performed before the application goes into production, is what we can basically called as a shift left methodology, or what we can achieve through this is what we call as DevSecOps. Now, what exactly is DevSecOps? DevSecOps, the final effort of DevSecOps is to make secure by default. So how that can be done is by integrating security via different tools, creating so you inject your SAST, you inject your dependency scanning, you inject your container scanning tools, etc. All kinds of tools within your pipeline. Now, how that can be done is, and again, the tools that you're integrating, they cannot be manually executed. They all have to be executed in an automated fashion, and that's how you basically get a security as code culture. So right from the start, that is from the time the application gets pushed into Jenkins up to the time when it gets deployed into production, all the tools must be executed in a timely manner, in an effort based manner, right? And lastly, DevSecOps will be successful only when you promote cross-skilling. And cross-skilling can be promoted by educating your devs or your ops with security knowledge. What about you explain them about security vulnerabilities, you explain them about security issues. Now, why do we need DevSecOps? As I said earlier, DevOps moves at a very rapid pace. Because things are deployed at large scale and at very fast pace. Now, in that kind of an environment, DevSecOps makes it easier to manage the rapid pace of development by integrating these various tools into your pipeline. DevSecOps allows for much smoother scaling of processes. So once you have identified a tool and integrated in one application, you can take it and push it to different different other applications in your organization, and ensure and you basically get a good scalability. Also, DevSecOps helps in creating a secure by default environment. Now, how does DevSecOps help in creating a secure by default environment? Because as the tools start spooling out vulnerabilities, the developers will take some time in understanding those vulnerabilities. But after a certain time, after a certain age or maturity level, the developers will start coding things securely, will start deploying the infrastructure securely, right? So that's how the entire process uh, helps in gets created by us. So an entire secure by default environment gets created due to the positive feedback that is coming out of these tools. Now, how do we do DevSecOps? The first thing that we need to do is at the developers and at the developers workstation, install what we call as pre-commit hooks. Now, what are these pre-commit hooks? Now, you guys must have heard a lot about these breaches that have happened where sensitive information gets leaked into sensitive information that gets leaked into your Git repositories or your public repositories like your AWS access keys, your GitHub tokens, etc. Now, how can that be avoided? That can be avoided by making use of what we call as pre-commit hooks. What these pre-commit hooks do is they have a regular expression-based checks where whenever the developer is performing a check-in or performing a commit or a push, these rejects they get activated and they check if we are uploading any sensitive information. If we are, then it will block that commit, it will stop that commit or that particular push. And one such tool to help you do that is Talisman. The next thing that we want to look at is secrets management. So in a DevOps environment, you'll never see that the entire pipeline is held or is stopped for the administrator to come and push in the credentials of your database, right? That is not how DevOps works. In DevOps, everything is automated. So then what about the credentials? Where will the credentials be stored? The credentials are either stored in configuration files or in the environment variables in a DevOps environment. But this information is stored in clear text, and this is a big issue from a security perspective, because if there is any compromise, even in your Docker system, your environment variables can easily get exposed, exposing your sensitive information. So what can we do? So in a DevSecOps environment, having a secrets management solution is extremely important. Now, what this secrets management solution would do is basically tokenize your credentials and convert them into tokens. So you inject your credentials, you save your credentials into your secrets management solution, and the secrets management solution will in turn give you a token, and that token is what you need to push into your code. Now, when Jenkins builds your code and deploys it into your staging or the production environment, when the application is running in the staging or the production environment, the application will use that token to fetch the credentials from the Vault server or your secrets management server. And one such tool to help us do is HashiCorp's Vault. And Vault is a simple Go binary. All you have to do is execute that binary, set it up, and it can easily convert your credentials into tokens. Now, one good question that people ask generally is that what if somebody gets hold of our tokens, right? So if somebody gets hold of your tokens, they can easily go ahead and access your credentials. So the basic premise on which the secrets management solution needs to be designed is that your your secrets management solution or your vault solution should not be accessible to your developers. The vault server should only be accessible to the production servers or uh, or to the administrators. If the developers are having access to the production vault servers, then there is definitely that is definitely a big security gap that needs to be addressed first. Now, the developers have checked in their code, and now till here we are rest assured that our source code does not contain any sensitive information. But what if our source code contains a vulnerable library, right? For example, your application is developed using Struts2 web framework in Java. You've developed a fantastic application. You've coded everything correctly using all security best practices. There is no SQL injection, there is no cross-site scripting. But what if there is a vulnerability in the web framework Struts2 that you are using, right? That's exactly what happened with Equifax. They were using the Struts2 web framework, and the Struts2 web framework that they were using was having a remote code execution vulnerability. So it is extremely important that before you create a build or before you create an artifact, you need to run a software composition analysis tool that will basically go ahead and check if we are using any vulnerable dependencies, and that these tools can be executed by Jenkins itself. So Jenkins will execute these tools identify if there are any vulnerabilities. If there are certain vulnerabilities, then if there are high vulnerabilities, it will then kill the build, or it will not allow the build to proceed ahead, right? And dependency checker is one such tool for Java that can be used to analyze if we are using any vulnerable dependencies. Now, we've checked for vulnerable dependencies, but what about checks on our source code? What if my junior developer has written a source code which leads to a SQL injection vulnerability, right? So what to do about that? So here again, after dependency check, you can basically run a static analysis security testing. Again, the tool can be executed by Jenkins, and these tools, even the most basic tools, are very much capable to identify issues like SQL injection, vulnerable libraries being used, cross-site scripting, etc. FindSig bugs is one such tool in Java which can very easily identify SQL injection, insecure libraries like deserialization issues, cross-site scripting, stored passwords in clear text in your source code, etc. Right? So it is extremely recommended that you integrate these tools directly into your pipeline, even before your staging environment is set up. Now, once my staging environment is set up, that is, once my application is running in the staging environment, I now wish to perform a dynamic analysis of that application using tools like OWASP Zap. Now, OWASP Zap is a very good is an open source tool, and it has a rich API interface through which you can provide the URL of the application, and you can also provide cookies and user credentials through which the Zap can basically automatically execute the scans, right? And the APIs of Zap can be executed through Jenkins. So here, as soon as the application goes live into the staging environment, we can start execution of our OWASP Zap or any of our DAST tool, right? Giving us this additional security. Now, why is DAST required? We have already performed SAST. SAST is already checking out for issues like SQL injection, cross-site scripting. DAST is a preferred method. DAST is definitely an optional method, but if you can integrate a DAST tool into your pipeline, it will help you identify SQL injection, cross-site scripting lot more confidence, because SAST tools uh, SAST tools give out or spool out a lot of false positives, and using DAST in conjunction with SAST can help us eradicate a lot of these false positive issues. Now, next thing that we want to do is perform a vulnerability assessment. So we performed we've checked the application in the running state on the HTTP or HTTPS interface. But what if the application is having any other insecure services running on that particular IP address? So what do we generally run, right? We generally run these vulnerability assessment tools like OpenVAS or Nessus or uh, Qualys, right? And that is again something that we can do. So OpenVAS has an excellent CLI interface using which you can just provide the domain name or the IP address of the particular machine that you want to be scanned, and it will go ahead and scan that particular machine and identify if there is any vulnerable service running. Now, all of these checks can be done before the application goes into production. Now, once the application is live into production, what we want to check is whether the application is meeting our compliance standards. So a lot of regulatory compliance standards like HIPAA, PCI DSS, etc., they require that the application should not be running with root privileges. Now, a lot of developers, they create Docker images, and those Docker images are by default executed with root privileges, and that basically runs your application with root privileges as well. And that is in violation of any compliance regulatory standard, because almost all generic IT security compliance standards or best practices state that you should never run your services with root privileges or administrator privileges as far as possible, right? So now here, using this tool called as inspect, we can create a simple Ruby file where we can dictate the checks that we want to perform, and inspect will basically hook on to the Docker sock file, or your basically it will hook onto the running Docker container and execute that Ruby script. And using that Ruby script, we can then identify whether whether the Docker container that is running is compliant against our standards or not. Now, the next thing that we want to do is perform a container scanning, because a lot of our developers, they directly pull these images from Docker Hub or from other open source libraries. Now, we don't know the security posture of these open source libraries, whether these Docker images have been created with security in mind or not. So for that, what we want to do is perform the container security scanning using a tool called as Trivy. Now, Trivy basically executes all the scanning directly on the Docker registry, and it scans all the images and spools out all the vulnerability data. Now, vulnerability management lies at the heart of DevSecOps. Why? Because all of these tools that we've discussed so far, dependency check, findsec bugs, Trivy, OpenVAS, inspect, or Zap, right? All of these tools will generate vulnerability data in different shapes and formats. Now, if you give the reports of these individual tools to your developer will simply throw it out of the window. Hence, it is extremely important to normalize the data that is coming out of these tools and storing it in a single place, in a single application. And one such application that has been designed for this sole purpose is Archery, which is ArcherySec, which basically ingests data from all these tools that we've discussed so far and shows us in an interesting, in a very nice dashboard manner. Finally, we also want to till now, whatever we've discussed or whatever we've done gives us a good level of security assurance that we don't have any SQL injection, we don't have any cross-site scripting, we are not using any vulnerable dependency, our containers are fine, our containers are secure and compliant, we are not running any unnecessary services. But what if there is a zero-day attack, or what if there is somebody has still found a SQL injection issue in our application? We would still want to go ahead and stop that, and not just stop that, but also identify the endpoint where it is being exploited, right? And this is where mod security comes into play. So mod security is a web application firewall that will sit in front of our production application and identify any potential attacks on our application, right? And this is the complete DevSecOps, and this is how you can have this is a sample DevSecOps lab that we have created for our DevSecOps training, and this is the high level architecture of that entire lab. Now let's look at the video of all the stages that we have discussed so far. So here the developer is trying to input some secret key, and as we'll see, Talisman will stop it. Now here we've run dependency check, and dependency check has identified 38 high severity issues. So we are now going ahead and modifying the versions. Now we are executing the findsec bugs application, and it has identified one high severity issue. And now we are running our Zap scanner. All of this is completely automated. Now we shall execute the scans on our infrastructure. So Claire is another tool that can perform container scanning. And this is OpenBAS in action. And here we are auditing the Tomcat Docker image using inspect. Finally, we are now deploying our web application firewall, which detects SQL injection. And the entire ELK system has been set up to identify the endpoint. Finally, we're having the archery sec, which is a central vulnerability management, where all the tools are pooling their data. So I hope you guys enjoyed this video. The video is live on YouTube at this particular link. You guys can go ahead and see it. And these are some other tools of trade that I was talking about. So all the stages that we looked at: pre-commit hooks, software composition analysis, SAST, secrets management. There are different tools that are being listed over here. You guys can go ahead and try any of these tools. Now, does programming language really matter? So programming language will matter only in the SAST and the software composition analysis stage, because different tools, because certain tools have support only for specific languages. There are however tools like SonarQube that support multiple languages as well. So these are the different language specific tools for software composition analysis and source code static analysis. And this is a sample implementation of the entire DevSecOps lab for Ruby. Now, the thing to note here is that we've changed only the SAST and the SCA tool. Same goes with PHP. Again, we've changed only the SAST and the SCA tool. Same goes with Python. We've replaced with Pandit and Safety. And finally, Node.js. We have Node.js scan and npm check. Now, the simple thing with DevSecOps and whatever we've discussed till now was all technical solutions, but all of these technical solutions will go waste if we are not focusing on the cultural aspect. Now, the cultural aspect, it's very important to understand is that the developers are more engaged into functionality. They are not fixing security issues is a big headache for them as well, right? So you need to encourage the security mindset uh, by creating bug bounties, or by awarding the developers for finding security related issues, right? Security team also needs to collaborate and train the developers regarding the different tools and different techniques of secure of different vulnerabilities, right? Focusing on collaboration and inclusive culture is the most important aspect in terms of culture. So the basic thing is that the security team should try to eliminate the need of dedicated security team, and all the changes in the environment, all the trainings and all the bug bounty programs, etc., should be driven by the security team, so that they create what we call as security champions. Security champions are basically those individuals within the organization that are not from the security team, but are actually people from the development or the operations team that have the security know-how or have the security mindset. Few references. Now, finally, key takeaways from this is that again, security becomes everybody's responsibility in a DevSecOps environment. So a developer cannot say that security is not my responsibility, or an ops guy cannot say, I don't look after security, please go to the security team. Embrace security as an integral part of the process, right? Use feedback to refine the process. DevSecOps is all about feedback from these tools. So the tools will, so if you run, let's say Trivi will continuously start giving you vulnerabilities until and unless you create a secure Docker image, right? So this is how the entire feedback process will help you in creating a secure by default kind of an environment. And lastly, DevSecOps is not a one size fit all. Your mileage will vary. So, for example, you may not be able to take the entire DevSecOps pipeline implemented in one application and push it on to the second application, because it all depends on the line of codes, on the technology, etc. So you have to basically perform trial and error at every implementation. Thank you.